Good morning to one and all. Myself is Mrs. S. Sangeeta, working as an assistant professor in the Department of Information Technology. In today's class, we are going to see the subject object-oriented analysis and design. So from Unit 3, we have one topic which is called UML sequence diagram. The topic today we are going to see. So actually, what is a UML sequence diagram? A sequence diagram is nothing but it's a kind of UML diagram which shows the interaction between the objects in a sequential manner. That is the interaction between the objects in sequential order. So here we will have more number of objects in our software. Those objects will interact among themselves for some kind of purpose. So for that purpose, the objects are interacting and they are doing some task. So how to identify the sequence of interaction, that is sequence of messages passed between the objects. So for that, we need a kind of diagram in order to identify the sequence of message passing. So here the UML sequence diagram is doing that role. UML sequence diagram is recording the message sequences by numbering the messages. Okay, and then by using the structure of the sequence diagram, we can identify it so much easily. Okay, so now we will start from the notation. So the notation, basic sequence diagram notations. So here the main thing is the lifeline boxes and lifelines. So actually, what does mean by lifeline box? I will show you. You see this diagram. So actually, this is a kind of sequence diagram. So in this diagram, we have two objects called register and sale. And under register and under sale, we have some dotted lines, no? So this is called lifeline. Okay. So what is the purpose of line? Lifeline means so we can identify how long the object will exist. So the purpose of the lifeline is just to identify or know the lifetime of the particular object's existence. That's all. So this line is called as lifeline. And then lifeline boxes means so for some period only the object will be active during its lifetime. So, if it is in active state, the lifeline box will appear. And then once it's a lifetime, that is, if temporarily it's not active means the lifeline box will be terminated. Okay. So this is the difference between lifeline and lifeline boxes. So messages. So messages are nothing but the objects will interact among themselves by communicating through messages. Okay, so here the messages are the message expressions. They are mentioned on the arrow between the two objects. So actually the two objects are there. They have their own lifeline. So if one object is communicating with another object using the message means, we will mention one arrow from the first object to the second object. The base of the arrow will be touching with the lifeline of the first object and the tip of the arrow will be touching the second object. So on that particular arrow, we will mention our message expression. Okay, so and then an open message arrow means an asynchronous message. So here the time ordering is organized from top to bottom of lifelines. So time ordering is nothing but so in which order the messages are sent. If if it is the first message, the message will appear at the top. If it is the last message in the diagram, the message will appear at the last position. Okay. So based on the messages appear on the arrow, we can identify the time ordering. Okay, next the message expression. So there is some syntax for message expression. So the syntax is return is equal to message of parameter and then parameter type. So this is the syntax for message expression. Return is equal to message of parameter and its parameter type. So here the parentheses are usually excluded if there are no parameters. So we will see some examples for message expression. So just simply we can mention the messages without parameter. That is one kind of representation. So another type of representation is mentioning the message along with the parameter. And then the next one is the return value, which is equal to message expression. And then within the parenthesis, we will mention some parameters. So these are some examples for message expression. So this is one example for sequence diagram. Just to see this diagram. So in this diagram, we have two objects which are called register and sale correspondingly. So we have two lifelines and lifeline boxes also. So for register, there is one incoming message which is called do X. So that is the first message received by the object which is called register, and the message received is do X. So this is the first message, but we don't know who is the sender of this message. If suppose there is no sender name mentioned in that message, that is called as found message. Okay. So next, the bar, that is lifeline box or execution, that bar, vertical bar is called as execution specification bar, which indicates the focus of control. So that is during which period that particular object is active. And then typical synchronous message is shown with a filled arrow line. That is on the arrowhead, we mention the message name. So the first register is sending do a message to sale. Here the receiver is sale, the sender is register. So the second message also sent by the register to sale. And then the third message do C is sent by register to sale. So now only the sale object is responding to register using do D message. So this is one example for how to represent the messages in sequence diagram. So the next one is messages to self or this. So messages to self is nothing but that one object sending the message to itself. That is called self message or this message. So in this diagram, we can get the concept clearly. Register. So here, the register is sending clear message to itself. So the next one is creation of instances. How to represent the creation of instances? Instances are nothing but some objects. So here we can create some new objects. It is possible here. That is one object which is capable of creating another object. That is called creation of instances. So how to create instance or object? How it is possible? We will see that using one simple example. Here we have two objects called register and sale initially. The sale object is sending one message which is called create of cash tender. Using create message, it's a predefined message. Cash tendered is the parameter. So using some create message, it is creating the object called payment. Okay. So by using create message, we are able to create one new object. Okay. Next one, the object lifelines and object destruction. So object destruction means it's nothing but just destruction of an object's lifetime. Okay. So here we see the diagram. There are two objects called sale and payment, and there are two lifelines. So the payment, you see the lifeline of the object payment. The lifeline is entered here using some X mark, and we have some stereotype. It's mentioning the term which is called a destroy. The destroy stereotyped message with large X and short lifeline indicates explicit object destruction. The object is destroyed or destructed here. Okay. So furtherly, we cannot use that payment object for any purpose. That's all. So diagram frames, here we have loop. Loop means some number of messages are sent some number of times. Okay. For example, if one object need to send one particular message 10 times to another object, means how we have to mention it in sequence diagram means you can use loop frame. So you see the diagram. So here in the leftmost top corner, we have mentioned the term loop. And then in that loop, there are two messages mentioned. The first one is the message from A to B, which is enter item message. The enter item message is having two parameters called item ID and quantity. And then after receiving that message, the object B is responding to A using description and total. So where it happens means in point of sale case study. So when the customer is arriving to POS terminal with some goods for purchase, he will record, that is the cashier will record all the items and will calculate subtotal each time, and finally he will total all the items. He will prepare total for all the items. So in that time, what is happening is, if the customer is having 10 number of items, so 10 times the cashier needs to scan that particular item using barcode scanner, and he needs to calculate subtotal. So this is repeated 10 times. It is depending on the number of items the customer is having. So likewise, if we need to do some task, some countable number of times, we can use this loop frame. That's all. So this is one example, that is orchestration example for representing UML sequence diagram. So that's all. Here we have some objects called client, orchestration, service, service tool, like that. So these are called as objects. And then the dotted lines or lifelines, and then lifeline boxes are there. And we have some messages called invoke orchestration, message 1, message 2, and message 3. That's all. So that's all, students. I think now we are clear about UML sequence diagram. Thank you for listening.